This week we'll learn to use raster analysis in ArcGIS Desktop to create flood hazard vulnerability and flood risk maps. There are two primary types of spatial data, vector data and raster data. The data sets we worked with in the walkability analysis, such as student housing locations, road networks, and surface areas, are all vector data. Vector data includes features like points, lines, or polygons. You're probably familiar with the attribute table associated with a vector shapefile, with each row representing a discrete point, polyline, or polygon. Raster data is used when we have a continuous surface of value, such as elevation, temperature, precipitation, or flood risk. It can also be an image, such as a satellite map, a land use map, or a picture. A raster dataset is stored as a matrix of cells, or pixels. The size of a pixel determines the resolution of a raster or its spatial granularity. The smaller each pixel is, the higher the resolution and the more details the raster contains, which generally means the size of the file will be bigger. When you import a raster dataset into ArcGIS Desktop, the different values in cells will be represented in different colors. Like this digital elevation model I downloaded from the National Maps shows, you can see here its lighter color represents higher values and the darker color represents lower values. From the metadata of this raster I downloaded, I know that the value here represents elevation in meters. So the lowest point in my raster is 8 meters below sea level. I also learned that the resolution of my digital elevation model is a third of arcsecond, which is about 10 meters. So each cell in my raster is roughly 10 by 10 or 100 square meters. This digital elevation model comes with spatial reference, meaning that ArcGIS knows where to put it on a map. I'm adding a base map here, and you can see it covers parts of Louisiana and Texas, including my study area, Lake Charles. If you import image into ArcGIS, such as the scanned zoning map, it will be also a raster dataset, but without the spatial reference. In this case, you will need to georeference the raster before it can be shown in the right place on the map. There is a link to the georeferencing tutorial below. Now let's see what we can do with raster data in ArcGIS Desktop. In the layer property symbology, you can change how the image is rendered. Instead of stretched colors, you can display values in categories. You can set the cutoff value and color in each category. Like I can show areas with negative elevation in a different color here. You can also use image analysis under the Windows menu to adjust the image, such as changing its contrast, brightness, transparency, and you can also clip image and display hill shape effects using the image analysis window. You can add functions to a raster dataset, which are operations on the fly, so they take shorter time to process than typical ArcGIS tools, which will create a new dataset. There are toolboxes and tools specifically for raster data processing. The 3D Analyst extension, for example, allows you to visualize and analyze raster data with a z-value. Conversion tools and data management toolboxes contain tools for raster data creation, conversion, and processing. The Spatial Analyst extension also includes many tools for raster analysis, such as surface analysis, weighted overlay, and raster calculation.